you. I want to start off and just mention I've been to a lot of events, and I just want to give a round of applause for the conference organizers. This has been an amazing event here at YGLF. So my name's Bret Little, and I'm here to talk to you about JavaScript. And I'm not here to talk to you about like the exciting new framework or even the sexy things about JavaScript. I'm here to talk to you about maybe the dirty parts of the language, which is why I call it the bowels of JavaScript, specifically error handling in JavaScript. Start off again, my name is Bret Little. I'm a senior software engineer at Canopy Tax, where I am in charge of front-end development, a little startup in Utah. Most importantly, though, I am a father of 3 amazing, wonderful little girls that I love very, very much. But Utah, if you don't know where Utah is, it's in the middle of the United States, kind of in the west side, right next to lots of amazing mountains. It's where NGConf React Rally is held. If you're ever in Utah, please hit me up. I'll show you around. I took these pictures. They're really close to where I live, and it's an amazing place to be. But I'm here to talk to you about JavaScript, and JavaScript errors, specifically, they burn. And when I say they burn, what do I mean by they burn? Well, whether you know it or not, chances are, right now in your application, your users are experiencing errors. And about a year ago at Canopy, and I'm revealing a little bit of dirty laundry to you here. Like, this isn't the exact graph, but about a year ago, we decided to start tracking errors in our application as a percentage of unique users. So, of all the users that use our app on a day-to-day basis, I wanted to know what percentage of those users, unique users, were actually seeing errors. Me, the optimistic type, I thought it'd be like 1 or 2% maybe, but actually, we were averaging around 10 to 15%, and there were some days up to 30%, which is absurd. That's ridiculous. 30% of our users on a day saw some sort of error. And so I want to encourage you to get back to your office and find out this metric. If you don't know what this metric is in your app, it's something that you should know because it's affecting your users. And if you don't know about the error, how are you ever going to fix it? So how do you even figure this statistic out, though? There's a number of tracking services that are out there. I'm not going to spend a huge amount of time on these. Some of them are free, some of them are cost, some of them are self-hosted, some of them are entirely hosted for you. It doesn't matter. The main point is you need something. So now, me, your doctor, I'm coming to you here. I'm asking you a difficult question. So who here uses an error tracking service inside their app? Okay, so if there's nothing that you take away from this talk, nothing else, go back to your office. It'll literally take you 5 minutes to set up one of these services inside your app, and it'll make all the difference for your users. So to start off, though, I want to talk a little bit about how do these tracking services work. So they work through a variety of mechanisms inside the browser, but at the key root of them is window.onError, which is a global callback that will get executed whenever there is an error inside your application. Specifically, when this is executed, we have this message which describes the error that happened, the file number, or the file that the error originated from, the line number, and then the column number. Column, because if you minify your code to 5 lines, you might have 10,000 columns. Then we also have an error object. The error object is really important. Actually, all of the other parameters are derivable from the error object, but we'll talk about that more in a bit. But this is really how they work at their core, these error tracking services. So when we put this inside our app, as you would expect, we saw a lot of these. I bet you've seen these inside your app too. Cannot read property such and such of undefined. Okay, well, I need to fix that. We also saw a lot of these, and I had no idea what this was. Failed to fetch. Okay, failed to fetch. Something didn't work. Thing is, though, there was no stack trace with this. It just said failed to fetch. I have no idea. Why is it failing? I've got no clue. Okay, well, we also saw a lot of these. Object, object. Who's seen this before? Okay, well, that's all it tells me. It just says object, object. It's a string. No stack trace, no nothing. And I'm like, I'm screwed. What is that? And we didn't just have like 5 or 10 of these. We had like thousands of these. All right, this is bad. This is really, really bad. So let's talk a little bit about how just error handling works in JavaScript before we kind of dive into some of those. So this is really basic. but we have this function make error. We execute make error. We're declaring an object, and then we're accessing a property on that object that is not defined. We're going to get that first error. Everybody's seen this before. But the important thing to realize is because we're triggering an error, that error is going to show up inside window.onError. When it shows up inside window.onError, we'll have a stack trace, we'll have an error message, we'll be able to debug that. That's great, right? Also in JavaScript, we can dynamically create errors. Specifically here, we're creating this tricobezoar error. You do that by saying new error, you pass it a string of some sort, and then you throw it. When you throw that error and you create it, it also bubbles up and gets inside window.onError. And then you can track that, you get a stack trace, everything's good. You can actually find that error when you want to. Now the question I have for you is what happens when you throw a non-error object? Right here, we're throwing a string. You could throw an object literal, you could throw all sorts of things. The language doesn't stop you. Who thinks this is good? Who thinks this is bad? Who thinks this is bad? This is definitely bad. Why is this bad? It might be worth considering what is an error object. An error object is when you say new error, we create this new tricobezoar error. The error object that's created has two properties on it, a message property and a stack property. The message property is whatever you passed into the constructor, happens to be this string tricobezoar, but the stack property is a magical property that is computed and calculated at the time you create the error. Not at the time it's thrown, but at the time you create the error. And that is a browser-specific stack trace, which is specific to the browser, and it helps you find where the error is located. So now back to this question. Why is throwing a string bad? Well, it doesn't really do anything special for us, because now inside window.onError, the error parameter at the end ends up being a string. And because it's a string, you have no stack trace. And once you have no stack trace, you have no way to actually identify where this came from. And even if like your library tries to do some magic to throw a new error inside here, well, the context that window.onError is executed in is on a new round of the event loop, and there is actually no way for you to get a real stack trace once you start throwing strings. So never throw strings, always throw error objects. Okay, well, when we have synchronous errors, we can wrap them in a try-catch. Once we try-catch an error, we can have some custom logic to handle the error, but when that happens, we're no longer getting that error to bubble out inside window.onError, so we can actually like swallow the error. Okay, you generally don't want to swallow errors, but you can have custom logic to handle it, else bubble it outside the catch statement. Okay, well, what about asynchronous errors? So in this case, we have a try-catch around a set timeout executing a callback. So we are never going to get inside this catch statement. Why? Because this is asynchronous. Set timeout, make error being the callback, will never get executed, or it will never, the error that it's produced will never be bubbled into this round of the event loop. It's getting executed on a whole new round of the event loop, so it's not going to show up in the catch statement at all. But luckily enough, this error will show up inside window.onError, so at least you can still debug it, but it's not going to show up inside the catch statement. What about promises? Promises save us from asynchronous things. So we're calling makePromise, which is this function which returns a new promise. Inside there, we're going to throw a new error, a vermicularis error. Okay. Who thinks this is bad? Who likes this code? Well, the problem here is we have no catch statement. If you ever have a promise and you have a no catch statement and you're not bubbling that out, well, guess what? That error that's created, it could be you're calling a function that's not defined, accessing a property of an undefined or a null reference. Whatever error that you have inside this promise, if you have no catch statement and you don't bubble that promise reference out somewhere and have somebody else catch it, that will get swallowed, and you will never know about this error. The browser won't tell you about it, your error tracking service won't tell you about it, and you're essentially screwed. So if you're using promises, you need to make sure you have a catch statement. Okay, well, this previous slide I just showed you, we're just console.erroring the error, but really we want to log that. So if we want to bubble this out and get it into window.onError, how about we throw inside the catch? What do you think? Does this look good? Who thinks this looks good? No, this is bad. You're going to be worried about all my questions now. But so this is bad. Why is this bad? Well, promises themselves chain. And because promises chain, the catch statement itself produces a new promise. So if you're really going to want to get this error out of here, you're going to need to have .then, .catch, and a whole nother .catch statement. So like, it chains. And so now I'm like, how do I get this error outside of this stupid little catch statement because I want to make sure that it shows up inside my bug tracking service? Well, how do I do that? Well, I have a friend named Joel Denning who once said, all problems are surmountable by a well-placed set timeout. And what do I mean by that? We can do this. We can, inside our catch statement, we can just say set timeout, throw error. And because the set timeout is executing this callback on a new round of the event loop, it's going to be able to get bubble outside of that catch, and it's going to show up inside window.onAir, which is really ugly. This is like crappy, really crappy. But what else is wrong with this code? Well, our trick of Bezoar is back. We're throwing a non-error object. So remember, always throw error objects. Never throw strings. Never, ever throw strings or object literals. Always throw error objects. Okay, let's look at a fetch and example. So the fetch API. The fetch API is a new API for making HTTP requests that's native to the browser that replaces AJAX. Okay, we have this fetch API. We have this function runApp. RunApp is going to call fetch data with a bad ID. When it calls fetch data with a bad ID, well, we're going to call the native fetch API passing this bad ID to some server, and then we're going to get inside this .then promise. The response object that comes inside here is native to the browser. It includes a .ok property. If the response from the server is a 200-level response, .ok will be truthy. I don't really care about that. I care about when it's false. So in other words, we have a 400, 500-level error from the server. Something happened wrong. How do we create an error in a way that makes this useful to debug later on? Well, given what we've talked about, we could throw a new error. We could say error retrieving data. We could pass in the ID so we could see maybe it's null or undefined. And then down here, we can do this really crappy, like, set timeout, throw error stuff. You could do that. But a couple of things I don't like. A, this is weird. That's really weird. But then also, creating the error right here has some interesting effects. Remember I said when you create an error object, it creates a stack from the point it was created. So because we are creating the error object inside this callback, that means the stack trace that will be defined on that error will only have that part of the stack. It will not have any of the rest of the stack a part of it. For example, runApp. RunApp will not be a part of the stack for this error. So if this code fetch data is used all across your application, like 10 different people call it, you will never know which one called that function passing the bad ID. And so that really, sure, you're tracking this, it's getting to your error tracking service, but debugging this is going to be really difficult to do. So is there something we could do to make this a little bit easier? Well, say we create the error preemptively. We maybe won't use it, but just in case we need it, we can create it preemptively. And then if the response is not okay, we can mutate the error message, change it to whatever we want, and then we throw the error. If you do that, then the error that comes out of here will actually have the stack trace with runApp a part of it. And then you know who actually executed this. And this isn't necessarily something you always want to do, but this is like a tool in the toolbox to realize that you can create an error object whenever you want. But just because you created it doesn't mean you have to use it. And then you can think about when you're creating your error object in a way that later on when I'm trying to debug this, I can make it more useful so that I can actually figure out what the problem is. So again, make sure you get the stack right, because that's your best friend when you're trying to debug the problem. So now I want to give you a more complex example and take just a minute or two to go through this code. So right here we have a promise chain. So we've got this function run, and inside run we're calling make promise, and inside make promise we're calling make error, and in make error we're just returning a promise that is always going to reject and throw an error, a Trico-Bezoar error. Once it comes up here, we have our .then statement. We're going to change the data, but we're returning that promise. It's chaining up to here, and then we're dispatching the data, and then we've got this capture exception stuff, which is an easier way to do capturing the exception to get to the server or our error tracking service instead of doing our set timeout stuff. Instead, we can use whatever error tracking service, directly use the API to say, catch the error. That's what we're doing there. So the question I have for everyone is, does it matter where you put your catch statement in a promise chain? So notice we have two .thens. We have a .then here, and we have a .then there. Does it matter if the catch statement is here, or does it matter if the catch statement is down here? Who thinks the first one is like the right way to do it? The second one? Or it doesn't even matter. Maybe you should put it on both. So let's walk through this code and see if we can understand what's going on and see what makes a difference. So let's start with the left side. So when we make the error, it comes up here. There is no catch statement here. But because we're returning the promise out of here, it chains and it bubbles upward to here, and there's a catch statement there. And so now the error that was created down here will show up inside our error tracking service, and we'll be able to find it and get at it. That works. That's fine. Let's look at it over here, though. So now we make the error. It bubbles up to here, and we have a catch statement here. And now we're also getting the error to our error tracking service. So they look equivalent. Looks like it doesn't even really matter. But now I want you to consider, what if there's an error inside your dispatch code? If there's an error inside your dispatch code, say that the data that you got from down here and it's being dispatched, say the data has a property that's not defined and you're referencing it. Now you're going to get an error. But because you have no catch statement here, you're never going to know about that error. It's going to bust, it's going to break things, it's going to affect the user experience, and you're never going to know about it. And it's not going to show up on your tracking service either. So the lesson of this story is you always want to at least have your catch statements in a promise chain at the highest level of the promise chain. You might want it in both, because you might want to be doing something down here, checking for some specific type of error, and then bubbling it up if it's not that type of error and handling it in some special way. But always you at least want it at the top level of the chain, because you don't want to be excluding some of the code from getting caught, or from catching bad errors that you don't expect. So what about async functions in error handling? Async functions are almost like a sugary way of dealing with asynchronous code, making it feel like synchronous code. So this example here, we have a simple sleep function that produces a promise that will resolve after a set amount of time. Well, if you use this keyword async on a function, and when it's executed, so we're executing it down here, we're going to come inside here, and every time it sees the keyword await, and we invoke a function that produces a promise, it'll wait to proceed to the next line until that promise resolves. Okay, so it'll print 1, wait a second, print 2, wait a second, and then print 3. So how does this work with errors, though? Say our promise produces an error, a new Trico-Bizor error. Well, the question I have for you is, what's going to happen? Is this console.log statement going to print? Well, no, it will not print. And why will it not print? Because, remember, async functions, this await says, let's wait to proceed to the next line until that promise resolves. But this promise never resolves. And because it never resolves, it's never going to proceed to the second line. So, as with normal synchronous code, with async functions, we can use try catches and treat asynchronous code as if it was synchronous. And we can console.error our error right here. Well, what if we want to bubble this out to window.onError? Can we throw an error inside a catch statement here? And is that going to bubble out inside window.onError? Well, no, it will not. Why? Because async functions themselves produce promises. And so essentially, just because you have async function here, when you invoke that, it will have a .catch statement. It will also have a .then statement for whenever the function finishes executing. So if you're ever executing an async function, you always want to have a .catch statement. If you don't have a .catch statement, you potentially have errors in your app right now, and you don't even know about it because they're getting swallowed. It's a big no-no right there. So let's go back to these. Let's go back to these. So the first one, I think we've already kind of discussed how these can come about. The second one, though, failed to fetch. What causes that? Well, failed to fetch. We had some common code inside of our app that was using the fetch API. And so everybody making a network request would go through this common code. Well, inside this common code with the fetch API, the case that I showed you about assumed that we were always getting inside the .then statement. Well, there's actually a case where you never even get inside .then, you're just in .catch. And when does that happen? Well, that happens when the server's not available. So say you're making a network request to your server and it's completely down, it's not available at all. Then you're going to get a failed to fetch. And we discovered for our app that our rolling deploys were not working quite right. So when we were deploying a new backend and we were trying to unload the old version of the backend and bring the new one in, there was a period of time where there was no backend. And so we were getting failed to fetches. It wasn't very long, but that period of time was long enough to affect customers. Rolling deploys were definitely down. That was bad. Next problem is we had CORS issues. So if you do not set the proper headers on your CORS responses, you are never going to get inside this .then statement. You're going to immediately go to a .catch. It doesn't matter if the server returns a 200, a 400, or a 500 level response. If you don't have the right headers on your response, you're never going to get in here. You're never going to be able to look at response.ok. You're never going to look at the response JSON or response data or response status code. You're just going to immediately show up inside failed to fetch in the catch statement. So if you're seeing these inside your app, those are the two things I would look at. Making sure your rolling deploys are working, you have a backend available, and then secondly, if you're using CORS, is your CORS configured correctly? And for us, this was difficult to debug because it was only one of our backend services that had CORS correctly configured, and only when they responded with a 401 did they not set CORS headers. So that was like a nightmare to figure out that it was that API on a 401 that was doing that. So make sure that you're setting CORS properly across your app under all circumstances, under all, especially even error states. So then we also had this object-object error. And for us, this happened because we were throwing non-error objects. Specifically, we were throwing an object, in this case, which is actually the response of the whole response object from the fetch API, and we figured, hey, we want this to show up inside our tracking service. We want all the data a part of it. Let's just throw the whole object. But in reality, the way that throwing works is that's just going to be two-stringed into object-object, and that's what shows up on my bug tracking service is object-object. And it's just a string, and I have no way to track it. I have no way to figure out who caused it, where it came from, what's going on. And so the lesson of this story is make sure you always throw error objects. So, again, always throw error objects and promise.reject error objects. Also, make sure that all of your promise chains have a proper catch statement. And when I say a proper catch statement, make sure that your promise chains at least have a catch statement at the highest level of the promise chain. Maybe you could have more riddled throughout the promise chain, but at least make sure there's one at the top. Also, make sure if you're ever invoking an asynchronous function, make sure that that invocation also has a .catch statement. If you don't have a .catch statement, you're going to be swallowing errors and you will never know about it. Lastly, code defensively with debugging in mind. And this goes back to that example I gave where I created the error preemptively, even though I might not use it. So specifically areas of your app, the boundary points of your app, where you're going to be communicating with another system. You can never guarantee that that other system is going to respond with correct data. You always need to make sure that you are handling the edge case, that that system is not going to do what you expect it to do. So whenever you're making an AJAX request, make sure that you are handling the error case. And the way you handle the error case, make sure you do it in a way that makes it easier for you to find it 6 months from now. If you just forget about that error case, it potentially was going to be very, very, very hard to figure it out and understand where that rose later on. So I also need to mention a new API that is currently available in Chrome and Node.js. So I mentioned whenever you throw an error inside a promise, it gets completely swallowed. yes, it does get completely swallowed. And there's a reason kind of why the browsers implemented it that way, and it kind of relates to this code right here. So we have this promise where we're rejecting this promise with a new error. Well, there is no catch statement on this promise, but we might wait 5 seconds and catch that later on. It's really difficult for the browser to know whether or not you're going to handle your error scenarios with your promises. And because it's really difficult for them to know, they just assume that you know what you're doing. When in reality, usually when I don't have a catch statement, it's because I screwed up and I forgot to do it. So recently, Node and Chrome have added this new global event handler, onUnhandled rejection. And with onUnhandled rejection, whenever you have a promise that does not have a .catch statement on it immediately when the error is created, then this event is going to fire. And then you can essentially get a warning about it and say, hey, oh man, this might be a problem somewhere in my code. I am having a promise where I am throwing an error and there is no catch statement on that error, which is very, very useful. But again, this is only available in Chrome. I don't want to emphasize this too much as like this isn't available everywhere. And so if you are seeing these throughout your app, go fix them. And go fix them because in Edge, in Internet Explorer, Safari, Firefox, all those other browsers, this is not going to work for you. So you need to definitely make sure you're fixing those promise errors. Also, there's this other one, onRejectionHandled, that gets fired when you handle the rejection. So when this promise.catch statement executes, that event handler will also fire. So, I want to close with, if your app throws and there's no service there to track it, does it really make an error? Well, yes, it does make an error because your users are getting affected right now, whether you know it or not. Their experience is worse because of the errors that we have inside our apps. And also, if your promise throws and there's no catch statement, does it really make an error? Yes, it does. Even though it may be swallowed, and even though you may never know about it, your users know about it because your user experience sucks when those errors happen. So, thank you.